We started discussing about templates. We'll see detailing. Yesterday we learned about how do we use constructor, what is constructor and all. Now we will see about templates. Templates in object-oriented programming. Here some more important points are there, we will see. Actually, what is a template? Yesterday I explained. Template comprises of sample data and logic. Template comprises of sample data and logic, which you can implement according to your requirements. So what is a template? Yesterday I explained. Template comprises of sample data and logic, which you can implement according to requirements. Two purpose I told you. Templates are used in projects. I told you. What kind of projects? Templates are mostly used in what kind of projects? Remember, templates are used in rollouts. Templates are used in rollout, right? Templates are used in rollout and implementation projects. Implementation projects are nothing but end-to-end projects. In implementation projects, generally some modules our client needs to implement because they will not provide us all the data. We will just design a template and give to them, and they have to implement according to it, right? So templates are used in rollouts, and templates are used in implementation. Now, how do we design a template? So how do we create a template? Let's see. Actually, templates are technically created by using abstract class. Templates are technically created by using abstract class. We create templates by using abstract classes. So templates are created by using abstract classes. So contracts are designed by using interface, and templates are designed by using abstract classes. Entities and components are designed by using classes. I will show you a complete order now. Today we will see the complete order, how it actually works. That means we will see one implementation like this here. Actually, we will have contracts. And these contracts, we implement these contracts and we design templates. By using the contracts, we design templates. These templates we implement, and we design components. So we first create the contracts, and from the contracts we design templates, and from the templates we create the components, and by using these components we build the application. By using the components we build application, we build app. That is the actual flow. In real world projects, this is the basic flow. Internally so many things will happen. This is the basic flow. First we design contracts. From the contracts we design templates, and from the templates we create components, and by using components we build application. Actually, I hope you already learnt in JavaScript module system. We use the module system for building such library. I will show you how we can create and work. Before going to module system, first I will show you a simple flow here, how it works. So let's go to the project. Now, in this project, I am creating first a contract. In our index, I am creating a contract, that is interface. Interface and interface name, suppose I product. Now, as per the contract, product must have a name which is string type. Product must have a price which is number type. Product must have a quantity, that is also number type. Product must have total. Total is a method and it should return number. Product must have print. Print is a method which is void type. These are the rules. As per the rules, a product should contain all these. You can mention any optional also, but I am giving all mandatory. That is the contract. But in this, some details we design and some details we will leave it for client, so that whenever client wants, he can implement them. Then what we do is, we create a class by name product template. That is the class. This product template should use this contract. So how a class can use the contract? Class can use the contract by using implements. That means the product template implements iProduct contract. That means it is implementing that contract. Remember when to use extend and when to use implement. A class extends another class. A contract extends another contract. But a class implements contract. That means there is no confusion. So always the contracts are implemented. Contracts are implemented by class. If I have to extend a contract, that I have to do by using another contract. If I have to extend a class, I have to do that by using another class. So class will implement contract. Now, according to the contract, we have to mention these details. But we are designing a template where some details we will implement and some details we will leave for client. In that case, we have to mark it as abstract. We have to mark it as abstract. Abstract indicates that this class is going to have some members with functionality implemented, some members incomplete. That means it contains both complete and incomplete. Some members which need to be implemented and some members which are implemented. So we will implement these details. I will make public, so name, and here we will define some value. Means this is temporarily configured with empty string. Okay, later they can replace that empty string. We initialized with empty string. And remember, here we don't need to define the data type. So because according to the contract, its data type is already defined. The data type is already defined because you are implementing a contract, its data type is defined. Just you have to add access modifier. Similarly, I'm using public, another price. I will put some initialized number. Similarly, public, we have quantity, and that is initialized with also number. Now in this, we have total and print. This total and print will be, this total and print will be implemented by the client. That means that is not our responsibility. We will leave them for implementing for client. Then what we do is, if anything you have to leave for further implementation, you have to mark it as abstract. Abstract. So what is it? Public. Suppose the method is what? Total. And this total method is left here empty. And very important is, we are not defining the functionality and we are leaving it empty. And here the access modifier is defined here like this. That means we are configuring public, abstract, total. That means we are saying that this method's functionality is not our responsibility. That will be implemented later. So if any functionality you need to leave empty, then you have to mark it as abstract. Total and print are the functionalities which need to be implemented later. So here I will create another public, abstract, another method print, and it is void type. We are not giving the definition. That means the functionality is incomplete. That means now we designed a template. In this template, the functionality for these three are defined, but the functionality for total and print are not defined. Now this template will be used by our developers at client location. They will use this class and implement the complete functionality. That means now what we have to do is, we have to create a class, and the class is product component. This product component, tell me what I should do. I should extend this template or implement the template. I have to implement this template or extend the template. It is already a class now. It is already class. Already it is having some functionality now. Already it is having functionality. To that functionality, we need to add some more functionality. That means we have to extend. We have to extend. Extend which one? Product template. Product template. We have to extend this product template. And when you are extending product template, it is not a contract. Then why it is showing error? It is not a contract, but it is showing error because in a template, whatever incomplete members are there, those you have to implement. That means, excuse me. That means whatever incomplete members you kept in your template, those must be implemented. So template is not a contract, then why it is showing error? It is showing error because it is saying that you are trying to extend a template. In template, some incomplete features are there. you are extending the template means you have to fulfill the incomplete features. You have to fulfill the incomplete features. So now what we have to do here, we need to define here, first I will put name, and for name I will implement with functionality some name, and here I am defining price. Price is some price. After that I am defining quantity. Quantity is some quantity. After that total. Total is a method. This total method have to return, just it should return this dot quantity into this dot price. It should return number. And I need the print. So print is a method. This print method have to return console.log all the details. That means I will use name, this dot name. Similarly, next line price is equal to this dot price. And similarly, next line, so this is quantity is equal to this dot quantity. And in the next line, total is equal to this dot total. I need to print all the details. Now here, very important is, here we are implementing all the functionality. Here we are implementing all the functionality. And observe carefully, here we are implementing the name. We are implementing price, quantity, total, and print. Observe carefully. Here, what is the data type of name? String. If I assign any number into it, so it is not allowing. Have I mentioned the structure for name here? In the component, have I mentioned the type? In the component, have I mentioned the type? I haven't mentioned the type. Then how it is validating the type? I haven't mentioned the type. Then how it is validating the type? It is validating the type from the template. Am I right? That means template contains the structure. That structure it is using here. That means you here, now the point here is, so what does that means actually? The structure is hidden and only functionality is implemented here. The process of hiding the structure, and using only functionality in a class is called as abstraction. We call that mechanism as abstraction. Abstraction is nothing but in object-oriented programming, hiding the structure and giving only the functionality. Generally, people have a wrong idea. People talk about abstraction and they say data hiding. They talk about abstraction and say data hiding. That will be a wrong term actually. Why? Because you are not hiding the data. We are hiding the structure of data. It is not data hiding. It is data structure hiding. That means the process of hiding the structure and giving only functionality. That means we don't need to give the structure to people. That means they have to implement. If they have to implement, I don't need to give them structure, only functionality. Structure will be hidden. Only functionality will be given. That functionality they will implement and use it. So this mechanism is called as abstraction. This technique is called as abstraction. So technically here, so templates are technically created using abstract class, and abstract class is defined by using abstract keyword. It is defined by using abstract keyword. So syntactically, I will just give here abstract class and class name, that is abstract. Another important abstract class comprises of members need to be implemented. Comprises of members need to be implemented, which are marked as abstract. The members need to be implemented, then which are marked as abstract. That means syntactically, we have an abstract class and a class name. And in this abstract class, we have public, some abstract, here total, and total is a method. It have to implement a number. Means which should return a number. Now, very important, it can have public and print function with void, and it is implemented with functionality, then no need to mark as abstract. If it is implemented with functionality, then you don't need to mark as abstract. We need to mark as abstract only when it need to be implemented. If it need to be implemented, then we have to mark as abstract. Otherwise, it can have. And very important, if a class contains at least one abstract member. If a class contains at least one abstract member, then the class must be marked. Class must be marked as abstract. Then the class must be marked as abstract. We have to mark that class as abstract. So that is mandatory. If a class contains at least one abstract member, it should be marked. So abstract class hides the structure, right? Abstract class hides the structure of member. So it hides the structure of members and provides only functionality for implementation. So the process of hiding the data structure and the process of hiding the data structure and providing only functionality to component is known as abstraction. We call that mechanism as abstraction. It is called as abstraction. So that means we don't need to define the structure while implementing, because already the structure is defined. We have to just implement the functionality. So in real world projects, this is the order of design. First we design contracts. We remember there can be several contracts. There can be several abstract classes. I will show in later examples whenever we work with Angular, right? Technically, when we are creating a library, first we design contracts. After designing the contracts, those contracts we have to implement and design templates. Those templates contains functionality defined, some functionality implemented, need to be implemented. And we give the template to component. By using that, we build the application. That means now what we have to do here, so we have to create an app. LET app is equal to new product component. By using the component, we build an app. So by using the component, we build an application, and through that app, we can access all these details. I am just accessing the print because all the details are already defined. If you want, you can customize. If you want, you can customize. So all the details are defined. Let's run this and see. So we will see here. Yeah. And here I will define TSC, that is index.ts, and node index.js, and you can see it is working fine. And if you want, you can customize with your values. So you can customize with your values. Suppose I want to change the TV name, then here app.name is equal to, suppose, some LG, LED, TV, something. And automatically I will compile this. Then we are updating those details and we are using it. Right? That is the basic mechanism of implementing the contracts and defining them. So this is a simple concept of how you design. So we have contracts and we have contracts, and we have abstract classes, templates, and we have components. This is one small example. This is an example how we can design and work with the contract. Right. Now here another important point here is right. So you don't need any breaking point and all these, right? Just concentrate on what you are learning currently. Don't get excited into topics. Later you will learn about all the concepts level by level. So our concept is to learn first language TypeScript, right? First we will concentrate on learning TypeScript first. Okay. So what is contract, what is template, and what is component? These are the three important options. Now another important, already we discussed about inheritance. What is inheritance already I explained. So another, why multiple inheritance is supported for interfaces. It is not supported for classes. We discussed at that point. What is the reason? The reason is the reason why it is not supported. The reason is constructor deadlock. That is the reason is constructor deadlock, right? Next, another important, you need to know about another concept, polymorphism. Polymorphism. All these you will learn in JavaScript 2 also. But here some changes, what are there? Those we are discussing. That's it. Because you have polymorphism in JavaScript, we can implement the same here also, right? Now, what is polymorphism and how it works? We will see one basic point. Let's see. So that means in TypeScript, what you are going to learn something new, we will see that. Actually, what is the concept of polymorphism? I will give one general example. So suppose first observe the general concept here. We have some devices, like we have a device called pager. We have a device called pager. We have device like digital organizer. We have like camera, and we have phone. Actually, in early days, we used to have a device called pager. Pager is a device used for sending SMS, and it is for only SMS. That means you can send SMS to any person remotely through this device called pager. It is used for sending only SMS, nothing else. Before mobiles came, we have these pagers. Only SMS you can send. Actually, suppose you see the pagers look like this. This is pager. This is pager. These are pager devices, and these pager devices are used for sending SMS. Only SMS we can send by using this device. And we have digital organizers. Actually, digital organizers are used for address. That means you can store your contacts, you can store some notes, you can use as calculator, you can store appointments. So it provides alarm, it provides calculator. All these things are present in digital organizer. Early days people used these organizers also. Digital organizers also people used very much. So digital organizer, it looks like this. This is digital organizer. People used these type of digital organizers very regularly in the early days. These are used for storing appointments, alarms, calculator, everything inside this. And we have cameras for photos and video, and phone is for calling. Now, early days we were doing all this, and after that we came across with a device. We have a device called mobile. Mobile is a device. Now, after this device came, this device can do the work of pager, it can do the work of organizer, it can do the work of camera, it can do the work of phone. That means pagers gone, digital organizers gone, and now people are using these cameras, video, audio through mobile. That means one device can work for different situations, can do different types of tasks. This is called as poly. Poly means many. And morphos means forms. That means the ability of a device to work for different situations. For example, if I don't have a SIM card, I don't have an internet connection, then still I can use it as a camera. Then still I can use it for appointments, alarms, clock, calculator. That means it is not like without SIM card, without internet connection, it can't do anything. It can work for different situation. That means one device can have different behaviors. That is the mechanism of polymorphism. Polymorphism means we need to create an object in such a way that it can work for different situations. That is polymorphism. Actually, polymorphism means in object-oriented programming, many people, they think that function overloading, method overloading. They stop there only. That means they think that polymorphism is about overloading a method. Polymorphism is not overloading a method. Polymorphism is giving a behavior in such a way that one object can work for different situations. It is not about function is overloading or some other thing is overloading. It is about behavior. Polymorphism is not about overloading. Actually, people that uses overloading, that is the reason you will learn like polymorphism is overloading. But polymorphism is a behavior. That means we need to give an object in such a way that it can work for different situations. If it can work for different situations, that means it is exhibiting polymorphism. Let me take you one example, technical now. This is general example. That means a device can work for different purpose. Okay, let's do this technically now. See, technically how it works, I will show you. Now this is the program. Yeah. Now technically how this concept works. That means actually polymorphism. So poly means many, and morphos means forms, many forms. So it is a behavior given for component, so that it can work for various situations, so that it can work for various situations. It is a behavior given for a component so that it can work for different situations. That is actually the concept of polymorphism. I will show you here one simple point. See, now here I will create a class called employee. Okay, this employee have first name, which is string, and last name, that is also string, and designation, that is also string. Employee have these three details: first name, last name, and designation. Now I am creating another class called developer. Now developer is an employee, but he have some additional roles, some additional functionality. That means employee related all details he need to get. That means first name, last name, designation. In addition to that, some more details we need to mention. In that case, developer extends which class? Employee. That means he can use all these members. In addition to that, some more members you can mention. For example, here I am defining. So first name is equal to some, so I given some Raj. Some last name I given as some Kumar. Like this I am defining. And designation I will give as developer. And extra, it have an option like role. So designation. Yeah, designation. Okay. Yeah. And here I have another option, print. This print will print all details. That means console.log. It will print the details. It will print this dot first name space. It will print this dot last name, and it will print this dot designation. It will print the details. Okay. Now here we have to design the print method. Okay, this print method, this is an empty print method, no need of all this. Now here we define some extra details. Extra detail is here we are giving role, and I will just give details like developer role. Developer role is nothing but building, debugging, testing, deploying, all these things. Like this I define deploying all these. That is the developer role. And I need to print the details. And very important is, already first name, last name, designation are printed by this method, which is base class method. And extra I have to print role, right? In that case, how you can access the base class method in derived class? You can access base class method in derived class by using super. Super dot which method? Print. That means now the base class method is accessed in derived. Already I showed you base class constructor in derived. Base class method is accessed in here. That means it is printing first name, last name, and designation. But in addition to that, we have to print one more, console.log. We have to print that role also. That means here I will print this dot role. That means in addition to these details, it will print this one also. This is developer. And developer is adapting all the employee related features. In addition to that, role with some additional functionality. Okay, let's create another employee. So class, I am creating admin. Admin, this admin also extending employee only. Remember, admin is not extending developer. Admin is not extending developer. That means there is no relation between developer and admin. But both are what type? Employee type. There is no relation between these two, but both are employee type. Now what I am giving here is all these details are same. I will copy here. Admin have some name. So this is the admin name, and I will give designation as admin, and here I am giving admin role, and I just given some functionality like authorization, authentication like this, I define. Now I am printing those details also here. Now two employees are there. One is developer, another one is admin. And there is no relation between developer and admin. Only those two are using this prototype. That means they are using that employee type for accessing the data. That means employee is a class which is just used as a blueprint. So that these members are accessed and used. So we will create one more class here. I will create another class. This class I will give as manager and extends employee. And here I am giving some like Tom, some like Hanks, something like this. And designation I am giving as manager. And here I am giving manager role. And here some manager role, some approvals like this I given. Now very important is we are having 3 employees: developer, admin, and manager. Now my question is, tell me how I can access all these 3 employee details by using one object. I need to create only one object which can work for all 3 employees. I need to create only one object which should work for all 3 employees. Then for which class I need to create object? Understood the question? I need only one object that should work for all types of employees. Then for which class I have to create? For which class I have to create? For which class I have to create? If I create an object for employee, only employee will come. How developer details will come? This is not reverse mapping now. This is not reverse mapping. That means if you create an object for employee, see, let emp is equal to new employee. You create object for employee, only employee details will come. Role, responsibilities, all will not come. Right? And if you can answer this, that means you know polymorphism. People who claim that I know polymorphism in object-oriented programming, he must have an answer for this. That is what polymorphism is. Polymorphism means one object can behave as developer, it can behave as manager, it can behave as admin for different situations. How? You create for manager, only manager will come. Only manager will come. So this is the concept of polymorphism. So see what I am doing now here. I am creating. So LET, observe carefully. I am creating employee is an object, and it is an array type. It is an array type. Array type means it is allocated with multiple memories. In that first memory, I will allocate developer memory. In the second memory, I will allocate admin memory. In the third memory, I will allocate manager memory. That means the memory of employee is overloaded. The memory of employee is overloaded with 3 different classes. Object, how many? Only 1. But at 0 index, it will work for developer. At 1 index, it will work for admin. At 2 index, it will work for manager. That means now only one object which can work for all the 3. It can work for all the 3. This is polymorphism. That means this is polymorphism. So that means here we are creating one object which can work for all these 3. That means you created how many objects? One object only, but memory is overloaded. So memory overloading is the primary concept of polymorphism. It is not like function overloading, right? Memory overloading, right? See here. Now I will do one thing. I am using console log. Better I will use here so that I can show you in HTML page. I will use document.write. If I am using document.write, its intention is to use in HTML page. Okay. Now here again, let's keep document.write. Document.write. And if you are using document.write, make sure that at the end you are using a BR, line break. Okay. Okay. So here we are using document.write. Document.write. Not required. You can try console also, just so that it is more convenient to understand. Document.write. Okay. Now we have this employee object inside this TS file. We have that employee object inside the TS file. Now see what I am doing. Let's go to index page, index.html. In index.html, let's design doc type HTML head title some polymorphism. So morphism. Okay. And here I am giving the link. I am creating a link. Not link, script. Script source is equal to, we have src in that index.js. Now we have to first compile this now. That means I will transcompile that. So tsc index.ts, so that JavaScript will be generated for it. After JavaScript generated, here this is providing only this object. That is providing only that object. What I will do here is I will create another script. In this script, we can access that employee object. Employee object is present inside this class, inside that JavaScript file. I am writing here. So var designation, I am asking prompt. In that I will say enter designation. I am asking enter designation. After entering designation, because it is an array, you can see employee is an array. I am using a for var employee of employee. I will give this as employees. Okay. Let me compile again. Okay. That means employee of employees. Employee of employees. We are accessing every employee, and if employee dot designation is matching with the designation you entered, then only that employee related print method should work. Only that employee related print method should work. That means what we are doing, we are accessing this employee's object from this file. We are accessing that employee's object from that file. And we are, because it is an array, we are looping, we are accessing every employee. We are verifying whether employee designation is matching with the designation entered, and we are printing. Now, only one object is created called employees. And now this object should work for all three employees. Let's run this page and see. When I run this page here, it is asking for enter designation. I will enter designation. I will enter designation as admin. And I say OK. Then only admin details will come. Only admin details will come. I enter designation manager. Only manager details will come. I enter details for developer. Only developer details will come. That means actually to handle three classes, I need three objects. To handle three classes, we need three objects. But I created only one object which is handling all the three classes, three different classes. Remember, all are using employee only as a data type for name, designation, only for data. That means they don't have any relation between admin or developer or manager. If they are having relation with each other, then I can use multi-level inheritance. I can create an object for last class. Through that I can access all. But here all are different. If all are independent, all are different, then how you can create one object which can work for all the three? That means if anybody asks to prove polymorphism as a behavior, this is the good example. Because polymorphism is not about overloading function. Polymorphism is about overloading memory. It can be memory of a function. It can be memory of a class. It is overloading memory. It can be object memory. It can be class memory. It can be function memory. Anything can overload. Right? That is what actually the concept of polymorphism. That means technically, polymorphism means behavior. That means it overloads the memory. It overloads the memory of component to handle various functionalities. It overloads the memory of component to handle various functionalities. So that is the point. So you can simply say a single base class object can use the memory of multiple derived classes. That is how we define polymorphism. That means it is using the memory of several derived classes. One base class object can use the memory of multiple derived classes. So let's take one point here. So I will just give this example. What example we created? So example, we have to first create index.ts. In index.ts, this is the code. This is the code in index.ts. And here we created all these, employee and all this, right? Employee, developer, admin and manager, all are of type employee. And after that, second point, transcompile, tsc index.ts. Then index.html. In index.html, this is the code. We are importing it, and we are importing this object from this particular JavaScript. Because it is an array, we are iterating, we are verifying the designation is matching with the designation we entered, and if it is matching, then print method should execute. Print method for that particular object should execute. So that is the basic. This is a simple array technique, and there are so many ways. This is example I will give. There are so many ways. So many ways means actually, you see, there is another technique. You can write like this also. That means here I am writing like this. This is written like this, empty array. And here employees of 0, here we will use developer. Similarly, employees of 1, here we will use the memory for admin. Similarly, employees of 2, here we can use the memory of manager. You can declare like this also. You can declare like this also. Anyhow, you know, working with array, right? That means you are creating only one object and you are allocating multiple memories. And in such a way that in every memory location, it can do different functionality. In every memory location, it can do different functionality. That is the ability of this, right? This is the basic mechanism of polymorphism. So while working with object oriented, so few basic things: contracts, templates, and components, classes, and inheritance of classes, and polymorphism. Polymorphism, how it works. Next, another important, now in TypeScript, you have to know about another major, that is generics. Generics. These are new concept. You haven't learned these in JavaScript, or these you may not have came across in other technologies also. Generics is one of the key concept used in Microsoft technologies, because TypeScript is a Microsoft technology. So here it uses this generics very regularly. And in Angular, like library, so lot of generics are used. So that is the reason we should know about these generics. You may not come across with these generics in other languages, but they are very popular in Microsoft languages like .NET and all. Why? Because TypeScript belongs to Microsoft, and TypeScript is used in Angular. So some Microsoft related features are used everywhere. And Angular also depends on these generics for various situations. What is generics? I will tell you. Why you need this generic, I will tell you. First point here is, let's take a real situation so that you can understand. That means, what is the concept of generic? I will tell you. Actually, to understand the generic, suppose I am creating a variable. I am creating a variable as some price, some variable price. Now, very important is, into this variable I need to store some data, but the data comes from some API, some remote location, some that we haven't designed. Somebody else designed some data, and from there we have to access the data and use it. That means I am not sure what type of data is coming, but whatever data comes, I need to store. Then what should be the data type of price? Understood the question? That means I don't know what is the data type, but I must able to handle any type of data that comes in. Then what is the data type I have to define? I have to define the data type as any. But if you define the data type as any, now the problem is, suppose I define data type as any, and into that price some number is sent, it will store. Into that price later some string is sent, it will store. Understood? It will store. That means until the data comes, I don't know the type. But once the data comes and once I know the type, I should restrict only the type. That means once the data comes and a number is coming, and once number is coming, I know the type. And once I know the type, then I should not allow any another type. Then any is not solution. Any is not solution. I need to design this variable or property or anything. I need to design in such a way that it should be type safe. Type safe. Type safe means it should be ready to accept any type. But once it knows the type, it should not allow any another type. That's very good. That means we need to create type safe members. Type safe members means they are ready to accept any type. But once you mention the type, they will not allow any another type. They will not allow any another type. That is very good. Right? That is the concept of generics. Generics, actually, generics are used to create type safe components. Generics are used to create type safe components. Actually, type safe component initially can accept any type of data. Type safe component initially can accept any type of data. At the same time, it can also restrict the data type. Once it knows the data. That is very important. That means type safe component initially can accept any type of data. At the same time, it can also restrict data type once it knows the data. Until it doesn't know the data, it can accept any type. Once it knows the data, then it can restrict. That is actually type safe. And very important is TypeScript. TypeScript allows generic TypeScript allows, we have generic properties. TypeScript allows generic methods, and TypeScript allows generic classes also. TypeScript allows generic properties, generic methods, and generic classes. It allows generic types. So that is generic properties, generic methods, generic classes. Actually, generics allows generic constructor also, but in TypeScript it is not allowed. That means in TypeScript, generally generics can allow constructor also generic, but it is not supported in TypeScript. TypeScript allows only generic properties, generic methods, and generic classes. How we can create these generics? Let's see. First, one by one, we will see how do we configure the methods, classes, and all these options we will see. For example, let's go to the index here. I'm creating a class and a demo class. And this in demo class, we are creating a method. Suppose I'm creating a method, some addition, that is the method. And this addition method is designed in such a way. Suppose this addition method should be add. Suppose add, I will give add. Add should work for string and numbers or any type. If it is string type, it should number type, any type, it should work here. Actually, now in this add, we are defining the parameters. Suppose we have A and B parameters. Now return type, so also some number or string or some return type we have to define. Suppose I define number, then every time it will be number. And if it is A also number, B also number, all are number type only. I want this method to work for different types of data. I will show you real-time scenario. First, we need to understand the basic concept. So see here, I will make this add as a generic type. Generic types are defined by using like this. It is defined by using this angle braces. T is not the compulsory term. You can use any word, X, Y, Z, anything. T is a tradition to tell the type. It is ready to take any type. You can write the word type or you can use A, B, C, X, Y, Z, anything, doesn't matter. But traditionally it is dealing with type. So we give as T. In that case, this must be the type T. B also must be the type T. And this also must be return type T. Then it should return some value. And very important is actually when you are giving generic types, you cannot do directly any operation on generic types. That means addition, subtraction, like that, you cannot do directly any operation because we don't know the type. That means I cannot just give A plus B. It's invalid. It will not work because we don't know the type of them. Then what we have to do is we need to do that by using methods. Suppose I created a function called sum. It will take X comma Y, and what it will do, it will return X plus Y. Now this sum function I can access here and I can pass A, B into it. That's how we do. Directly operations are not allowed on generics because their type is unknown. We cannot directly do any operations on them. Then we create a function. Through that function, we can handle the functionality. Now important here, the data type of this A, B and add are unknown. So let's create an object. Let obj is equal to new demo, object for demo class. Through obj, I can access the add method. Observe carefully. This add method is expecting data type. And once I say the data type is string, automatically you can see A and B are string now. Now data type of A and B is string, and not only that, the return type is also string. Until I don't know the data type, it is ready to accept any type. Once you tell the type, it can restrict only the type. That means now A and B must be only string type. So I just define some Raj, some Kumar, like this I am defining. And I am using again, so add. This time I am passing number, and automatically you can see that it is working for numbers. A will be number, B will be number, it will be performing that operation. That means I can use this for different situation, and this is also one kind of polymorphism only. This is also one kind of polymorphism. That means it is having different behaviors. Actually, that is not behavior. That is the reason we don't put as polymorphism. It is not changing behavior. It is changing only type. Behavior is same. It is doing only addition. It is not changing the behavior. It is doing only one work, addition, but different types. This doesn't comes under polymorphism. Polymorphism means complete behavioral changes. But this is not polymorphism. This is designing a component type safe so that it is ready to accept any type. And once it knows the type, it will not allow any another type. I will tell you the situation here. Why you need such generic things? Why you need such generic concepts? That means, for example, I will give you one simple example. Suppose we are working with an application. Suppose you are learning some technology like Java, .NET, PHP, Python, some technologies you are learning. Now, by using these technologies, you will build an application. Depending on business requirements, that application uses different database. That means, remember, every application not necessary to use a database same. That means some applications use Oracle as database. Some application use MySQL as database. Some application use MongoDB as database. Different databases may be used. Some will use SQL Server as database. Now, these Java and .NET people have to provide a library. That means they need to provide a database class. Now remember, this class should be designed in such a way that it should work for any database. This database class should work for any database. That means to connect with any database and access it. But remember, once it is working for Oracle, it cannot accept the queries related to MySQL or MongoDB or SQL Server. It should strictly work only for Oracle. Understood? That means once you started using it for Oracle, it should work for only Oracle queries, only Oracle methods it should accept. It should not accept anything else. That means now how you will design? Will you design 4 different classes for 4 different databases? That is not right idea. We don't design 4 classes for 4 databases. We will have only one class, but that should work for all the 4 in such a way that initially don't know which database, but once you tell the database drivers, it will work for only that. Now, how to design a class in such a way that it is ready to take any data type, and once it knows the data type, it will not allow any another type. That is possible by using generics. We can do that by using generics. Generic allows to create such library so that initially it is type safe, and once it knows the type, it will not allow any another type. It is ready to take the type and it will not allow any another type. That is the concept of generic type safe content. Now, how to design this, that we will see in next session. Tomorrow we will see that, right? Tomorrow we will see example on this generic. 2 more important topics are there. We have generics and generics. We have enums. So, and we have modules and namespace. With these topics, we will finish all the TypeScript part. Then we will go into Angular now, right? For that, we need to finish all this. So tomorrow we will continue generics, enums, and how to work with them. Okay, right.